to the 30th lecture. So, here we have been discussing about the gravity gradient satellite, and we derived this equation last time. So, we will continue with this. So, while working here, this dot is not there. So, while working for this, we will require certain conversion, and we need to look into those conversion. So, let us write this h, which is the angular velocity vector. This we have written as I times omega. Okay. This is in the vector notation, and the same thing also in the matrix notation we have written as I times omega tilde, where I is the inertia matrix. Inertia matrix. Okay. Now, assume that first we have expressed this in one frame, which is E 1, E 2 and E 3. Okay. And in this frame, this is my H vector. Okay. So, now if I took another frame, say this is E 1, E 2, E 3. So, this vector is not changing, but its component will be different in this E 1, a small E 1, a small E 2, E 3 frame. So, that there we write H tilde prime, okay, in the this frame shown in the orange color. Okay. So, H tilde prime, I can write this as I prime times omega tilde prime, okay, where I prime is the inertia matrix in this frame, because as the frame will change, the inertia matrix will also change. Also, we are aware of that H tilde prime, this can be written as, if C is the transformation matrix from capital E frame to a small e frame, means we are going from capital E frame to E frame. Okay. So, this we can write it like this. So, H tilde, it can be described in this way. The same way, omega tilde also can be written as C small e slash E omega tilde. Okay. Now, we use this result here in this place. So, on the left hand side we can insert this equation, we can insert here in this, and we get here from this place C E times H tilde, this equal to I prime, and omega prime we can insert from here. This omega prime can be taken here, and this H prime is taken to this place. H prime we are inserting from this place to this place. So, we have I prime times omega prime, which is C E slash C omega tilde, and then what we are interested in, that this H tilde, this is nothing but I times omega tilde. So, this is I prime okay. So, this implies I prime C E slash E, this will be equal to, because omega is a non it is a not a null vector, and therefore, this quantities this matrix C times I, this must be equal to each other. And if we operate on this, so we can write it as and what we can see that this quantity is an identity matrix, and therefore, this gets reduced to I prime equal to C E slash E I C transpose E slash E. Okay. So, here in this particular equation the inertia matrix which is in one frame and we are able to convert it to another frame. Okay. So, say this I was in the capital E frame and then we can go to here as per this one we can go to this the small e frame and as we know that this inertia matrix is always symmetric and therefore, this I prime if we take the transpose of this. So, transpose of this will be equal to I prime and here in that case this gets reduced to okay. If we take the transpose okay, we will leave it because taking the transpose it does not matter here. So, we skip this process here. We will take up this part later on. So, this way we can convert from one frame to another frame. So, we need to utilize all these informations to work here in this place. Okay, so, now we can use these results here and also as per our earlier discussion this E cap O3 this is referring to the orbital reference frame. These are the unit vectors along the orbital reference frame 3 directions and with respect to this our body frame is oriented. Okay. Say this is E1 cap, we can indicate it by a B to indicate this is along the body frame. This is 2 okay. And you know that this conversion B3 it is related to the this C matrix which is going from the to the body frame from the orbital frame and on this side we have EO cap 1. So, this is the way this gets converted. Now, we utilize this information to convert this from one frame to another frame. So, this we need to express in terms of the body frame system. So, here let us say that this is a unit vector along the third direction of the body frame of the orbital frame. So, if we write in a proper way, so this will be equivalent to this is 1 0 0 okay, this part and then we will have C B 0 and here on this side then you will get all these quantities E cap B 1, E cap B here 2 and E cap B 3. So, this implies that this is your vector, this is nothing but this vector where because this quantity is only along the third axis. So, the other quantity they will vanish, this is written in matrix notation and this is the vectrix notation. And here the same way like once we are dealing with this. So, instead of writing it in a say the whole thing we do not want to mix up here, we have one unit vector here and this unit vector is converted to the another unit vector. So, in that case I will not write it like this, here this cap will not be there, only thing that we will have here components. So, instead of writing this then we should write in terms of some components say the E 1, E 2 and E 3, these are the components along the body reference frame 1, 2 and these 3 directions 1, 2 and these 3. So, then this vector is converted into this vector. While we write in terms of vectrix, then we have to show it like this. Okay. So, this vectrix, this whole vectrix is converted to this one, this particular one. Okay. So, as you remember that we can write this as, we can utilize this notation like this is a unit vector along this direction. So, we have converted this time this cross. Okay. So, this is E cap 3 cross. Okay. Because this is a unit vector. Okay. And then I double bar dot E cap 03. So, this part accordingly we can change it. Let me express it in some other way. First I will give you a generalized form and thereafter we will come to this part. Say if I have something like this omega tilde. So, this is a vector, this is a dyadic and this is a vector. So, this part obviously you know that this can be written as 0 minus omega 3, omega 2, omega 3 0, omega 1 minus, omega 1 0 and minus omega 2. And this part if you remember recall from the our earlier discussion. So, this can be written as I 1 1, I 1 2, I 1 3, I 2 1, I 2 2, I 2 3, I 3 3 and here then omega 1, omega 2, omega 3. Okay. Along the same line we have to change it here in this place and then our job will be done, and we will utilize these informations to put it in a proper shape. Okay. So, we have tau this equal to 3 mu by R c then this part I double bar dot O3. Okay. So, this we write as say in terms of the C matrix so, this will be C transpose times E B times 3 cross E cap, sorry this 3 is not there. Okay. So, this we are taking from the previous discussion where we have used this omega. So, this is a vector okay, which you get it from C times here another vector okay, which is in the orbital frame. So, obviously, if we are looking for this orbital vector. So, this orbital vector can be written as here in terms of C transpose E cap B. So, this is what exactly we have done. So, this E cap B, it does not indicate that this is just a vector along the any one of the body axis direction. It is indicating all the three, means I have this orbital frame E 1 0, E 2 0 and E 0 3, and then we have the body frame here, E B 3. Okay. So, E O 3, this is the vector here. So, this vector will have components along all these three directions in the body frame. Okay. This vector, this is a vector along the E O 3 direction. Okay. So, that unit vector, so this is given by this quantity. Okay. So, this is what we have done. So, we have expressed in terms of E cap B. So, this means that this is C transpose E cap B 1, E cap B 2 and E cap B 3. So, obviously, you can see that in the as per our previous in the rotation case, we have looked into that E O 3 vector, this can be expressed as a combination of let us say this alpha 1 times E 1 cap B plus alpha 2 times E cap B 2 plus alpha 3 times E cap B 3. So, instead of doing this, we are writing it in this format. So, this we go from the orbital frame to the body frame, and from body frame to the orbital frame, in which way we can approach. So, this is the thing which can be written. Okay, and because this is a cross here, okay, this is a cross here in this place. So, we need to be very careful while working here. So, it is something like if you remember that this cross, whenever we got a cross across this place. So, sometimes we have written this as like this. So, this can be broken in a format where it can be written as C transpose, and obviously, because we are C transpose you have written C, we are using like this E to E frame. So, we are going from orbital frame to body frame. So, we should write here B slash O E, B slash O means this is from orbital to B, and then we are taking the transpose of that to, and this transpose, this simply implies that C transpose B slash O, this equal to C O slash B. This is what we have learnt in our rotation. Okay. So, this can be written as B slash O E cap B, where remember that E cap B is nothing but this part, and then C Okay, so, we need to do some simplification, and then we will get the final result. Okay, this we could have done purely in the form of a vectris, and I will do that for you people, because that will be beneficial to because in the terms of vectrix we have not done earlier much of the things. So, therefore, I would like to do this part in terms of vectrix. Okay, so, here we need to put a cross, this is this part. Okay. Okay, let me explain this part, and then this part we will prove through the Vectrix method. Okay. So, E cap O 3, if we write this as C transpose B slash O E cap B, okay, and then there is a cross. So, basically the quantity we are writing, we can write it in this format. Yes, we have changed it to matrix there, where S is the skew symmetric matrix. We are using the earlier definition that any vector x tilde cross, this will be equal to minus, this is the notation we are using. Okay. So, if we use this notation here, so going into this part, or either you just take this part. So, this is 3 mu by R C cube, and this part can be broken like S times C transpose B slash O. See, there is a minus sign here in this place. Okay, so, if you use this notation and this part you write it as I times E tilde O 3. Okay. So, the whole thing will become very convenient to work with. So, I take you to the next page after this. So, now pick up this part from this place. This minus sign is here. So, we will put the minus sign in this place. So, the cross notation we are not using. Once we have written in this form, so this will be written like this, okay. And this can be reduced to this format, and this can be checked. Like you can see that if you have C transpose B slash O, if this is an identity matrix, on the right hand side here this transpose is not there. Okay. If you assume that C slash B transpose O, C transpose B slash O, this matrix, if it is an identity matrix, so immediately what we can see that this part will be equal to minus S E cap B, means here E cap B cross this quantity will be equal to minus S E cap B, okay, which is the definition we are using. Okay, x tilde cross this equal to minus S times x tilde. So, exactly the same thing is here. So, immediately for the identity matrix, if your C happens to be the identity matrix, it is a verified. But here this is a rotation matrix case, and for the verifying that indeed this quantity is equal to this quantity, we will have to expand it, and it is a little longer expression. You can check it yourself. Okay, you just expand it and then check whether this quantity turns out to be the same thing or not. Okay, so, therefore, this part what we have been writing here, this particular equation here E cross. So, this gets reduced to this part we have written from this place, and then replacing this as B slash O, and thereafter we have I times E tilde O 3. So, E tilde O 3, if I write it in this way, so this implies 0 0 1, while if we write it like this. So, this is just a unit vector in the third direction, which is written by 1 here. So, this is the difference. These are some of the simple manipulation we can always do. So, if you are not working in terms of, the best way of doing this is to represent this in terms of vectrix and then carry out the whole operation. Otherwise, convert it in here in this format and then work out. So, once we do this, then you check for some of the things here. Okay. And here also we need to convert it. So, this is I times this part we are writing equal to I times this part we have written like this, okay, this together. Then this also needs to be converted. So, if we convert this, so this will be C transpose O, sorry, this is C transpose B slash O times E tilde O, and this 3 we need to put it, because until unless we put this 3 it will this meaning will not be apparent. Only through this meaning this 3 it implies that this is 0 0 1, otherwise it will be something different. Now, this part, what is this quantity? C B slash O I and C transpose B slash O. So, we need to go back here in this place and compare with this. C is, okay, you can check it. So, this was in your inertial frame, and from inertial frame you have converted into the body frame. This I prime is the I prime is referring to the E frame. Okay. Like here H prime is referring to the small e frame, and capital E is referring to the inertial frame. So, small e is referring to the body frame. So, following the same notation, what we can observe from this place, this can be written as I or sorry B slash O I times, this will put in one bracket and we will write it separately. So, C B O I times C transpose B O. Compare this. So, this is C transpose I and here C is less. So, in this format what we can see that this is getting converted from if this refers to the orbital frame and this one refers to the body frame. So, we can see that this is converting from body frame to the orbital frame to the body frame. So, this is referring to the body frame and this is referring to the orbital frame. Okay. So, using this notation, then this can be written accordingly. So, let us move to the next page. So, this tau then gets reduced to minus 3 mu divided by R C cube and then C transpose B slash O, and then we have this skew symmetric matrix S times E cap B, and then this quantity which is nothing but inertia matrix expressed in the body frame. So, maybe I will put a prime here to indicate this is in the body frame. Okay. And thereafter, we have E tilde O 3. Sorry, this is we have already converted this. So, somewhere we have missed this part. This part we have written it. So, this part we need to correct here in this place. this is E tilde b or E cap b, whatever the notation we use. So, we can use that. The best way is to write in terms of tilde, but here we will continue with this part only. So, this mark it, this is the change. So, these are some of the errors that creep in while writing. Because we have changed this, okay. This part we are writing for E tilde O 3. So, this must be present here in this place, where E tilde O 3 is representing this quantity, which is shown here in this part. Okay. So, therefore, this can be reduced to E cap b. So, right hand side we have. Now, one thing you remember that still this is in the orbital frame, and we need to convert this into the body frame. So, instead of, because we have right hand side we have expressed the whole thing in terms of the matrix notation, therefore, I will put here tilde instead of putting a vector here in this place. Then multiply this both sides of this by, we have C transpose B slash O. So, this is in the orbital frame, and then we want to take it into the body frame. Okay. So, we will multiply it by C B slash O, perhaps over C we have not put the tilde. So, we will remove this tilde. Okay. So, if you operate on this tilde, so this will get reduced to, and then we are expressing this in the body frame. Okay. This is in the orbital frame. I have not put the tag, but this is in the orbital frame. Okay. This is in the orbital frame, or orbital frame to body frame conversion. So, this is converted into the body frame. On the right hand side we have 3 mu by R C cube, and then C B slash O times C transpose B slash O S E cap B, and then I prime E cap B. So, this quantity is nothing but identity, because it is a rotation matrix, and to rotation matrix this C transpose C times C transpose, that will be equal to identity, and therefore, this gets reduced to R C. So, this is your identity matrix, which we have represented like this. This is identity or unit matrix slash unit matrix. Okay. So, therefore, this quantity can be written as S E B cap times I prime, and if you do not want to write it in this way, so this can be written as, this minus sign can be absorbed here, and this can be written as E cap B cross. Okay. Okay. So, still this remains a matrix, this remains a matrix, this remains a vector. If you are looking to write this in terms of the inertia dyadic, so write it like this, I and prime I will put here, prime for we have used B. Let me check here what the notation we have put. Here I have not put here anything. So, this I prime is in the body frame. So, I will continue with I prime. So, this is I prime. So, E cap I prime dot, now we have written in terms of inertia dyadic, and this part, this gets converted into tau b. So, here we write is tau b. One thing I will draw your attention, that for this has been converted to the B frame by multiplying it by C B slash O. This is the transformation matrix which goes from orbital frame to the body frame, but the same thing we have not done for The same thing we have not done for the while converting from this here it is. So, see here in this place that this is tau and here this is EC and from there once we have converted in terms of the orbital frame here in this place. So, we have not multiplied on both sides by the transformation matrix. The reason is very simple, this EC and E3 vector they are in the same direction. Okay. Otherwise, I can also take the transformation matrix, I can multiply by the transformation matrix and I can do the whole thing, but it is the only thing that it is going to consume time. You can see that this is small thing, it has taken so much of time. So, this is only one way of doing, the other way of doing it is also there. So, but you need to understand it, okay, how we are converting and you need to be very careful. So, these are our two final equations that we have been attending it. And for you people, I will do this also in the Vectrix notation, so that you become convenient with the whole thing. Okay, so, we stop here and will continue in the next lecture.